spherical to rectangular equations, want to convert the equation and then graph. Number 49. So rho equal to 5 implies that we have x squared plus y squared plus z squared is equal to 25. So this is no more than just a sphere. With radius 5. I won't bore you with the particulars. Number 51. Phi is equal to power of 6. So let's look at the cosine of this phi. We know that this guy is given by z over rho, and so phi is power 6, so that's equal to z over rho again. So the cosine would be the square root of 3 over 2 is equal to z over rho. This implies, by just cross multiplying, that this is the square root of 3 times rho is equal to 2 times z. Now if we square everything here, kind of helps us out. So this implies that 3 rho squared is equal to 4 z squared. So the rho square is x squared plus y squared plus z squared. So here we have 3 times x squared plus y squared plus z squared, and that's equal to 4 z squared. We simplify all of this, that gives us 3 x squared plus 3y squared plus 3z squared, and then minus the 4z squared. So this becomes minus z squared is equal to 0. By definition, that 3 looks like he's one of those aliens from Star Wars. So by definition from section 11.6 for the quadric surfaces, this is an elliptic cone It's an elliptic cone in the top surface because phi is set to equal to 30 degrees. So it's in the upper octant, just quadrant for octant 8, since we have the space coordinate system of x, y, and z. The coefficient that's negative is with respect to the z variable, so this elliptic cone is with respect to the z-axis. It does not continue downward because, by definition, of phi. Number 53, rho is equal to 4 cosine phi. Well, let's see. We know that cosine phi is equal to z over rho. So let's use that. Replace this cosine phi with z over rho. So here we have rho is equal to 4 times z over rho. Multiply both sides by rho. So we get rho squared is equal to 4z. Now, the rho squared is x squared plus y squared plus z squared. So this implies that we have x squared plus y squared plus z squared. Let's subtract the 4x on both sides. 4z, excuse me. Complete the square on z. Take half of the 4, we get 2 squared, we get 4, we add 4 to both sides. So we have x squared plus y squared plus, this is z minus 2 to be squared is equal to 2 squared. Okay. So this gives us a sphere. The center don't want it all to go. Just my scribble scratch. The center is at 0, 0, 2, and radius is 2. So we go to where z is equal to 2. Let's say this is 2 here. So this is going to be the center, and the radius is 2. So we get this ball. It's number 55. So 55, we have rho is equal to cosecant phi. And let's see. Cosecant is the same thing as 1 over sine. So this is rho is equal to 1 over sine phi. We can simplify this. This is rho times sine phi is equal to 1. But what is rho times sine phi? Well, let's see. Well, if you recall, we have sine phi is equal to r divided by rho. So that implies that r is equal to rho sine phi. So if that be the case, then all we're saying here is that r is equal to 1. Well, if r is equal to 1, we write things from if it's cylindrical or spherical to rectangular so that we can graph. So r equal to 1 is the same thing as x squared plus y squared is equal to 1 squared. So this is a cylinder. There's no z, so the rulings with respect to the z-axis. Radius 1, obviously, right? Yeah. You get the picture.